Welcome to Matter Video 2. In this video, we're going to talk about the organization of matter and how you classify different substances. This particular flowchart is extremely important, so I'd like you to write this down somewhere in your notes. We're going to talk about this matter chart over and over. I'll ask you to draw out the matter chart, probably for your due now tomorrow, so it'd be useful if you could start to memorize how matter flows and how we would categorize different substances. So we're going to begin with our discussion of matter. We're going to talk about each side of this chart. So first, let's talk about what it means to be a substance or a mixture. So there are different types of matter. A substance is something that has a uniform or definite composition. And there are two different kinds of substances. So under the substances, you could be an element or a compound. Mixtures are a physical blend, so taking two substances and physically, like with my hands, I could put them together. So a physical combination or blend of two or more substances. So if you look here, we have two types of mixtures, homogeneous and heterogeneous. I know in 7th grade you learn a little bit about them, but I'm not sure if we remember, so we'll touch base on that later in the video. So first, back to this side. What is an element over here? An element we know is on the substance side, but what does it mean to be? So an element is a substance that you cannot decompose or you cannot break down into anything simpler. So I'll often ask, which of the following cannot be decomposed? And all you have to do is identify which one is an element, and then we know, okay, we can't break it down any further. Elements are composed of only one type of atom. So for example, if I had a piece of gold foil, the gold foil would be made up of billions of atoms. Each atom would be gold, but we can't break the gold down into anything simpler. Elements are represented by one or two letter symbols. The first letter is always capitalized. The second letter is always lowercase if there is a second letter. There doesn't have to be two letters, but if there are two, the second letter is always a lowercase letter. You may notice that some of the symbols for the elements don't match the sound that they begin with, and that's because they have a Latin origin. So when you see gold and you're confused by why it's AU, just realize it's coming from its Latin name. There are diatomic elements. Those are elements that only exist in nature in a diatomic form. So you could use this acronym Hofbrinkel, H-O-F-B-R-I-N-C-L, or Brinkelhof, B-R-I-N-C-L-H-O-F. It's a way to help you remember which elements are diatomic. We'll be responsible for knowing that, especially as the year goes on. What does it mean to be diatomic? Well, di means two. So if you have a diatomic element, it's an element that has to have this little subscript 2 up here. In their elemental form, they do not exist by themselves. They are always represented with a little 2. Okay, so we finished our discussion about what an element is down here. So an element is a substance, you can't break it down any further. Now we want to talk about, well, what's this thing over here? A compound. A compound is a substance that has two or more different elements. The different elements combine in a fixed ratio. So what we mean by that is, let's say you take water, for example, H2O. 2 hydrogen atoms and 1 oxygen atom always form water. Whether I'm talking about water or another chemist is talking about water, we will always use the formula for water as H2O, meaning 2 hydrogens and 1 oxygen. That is a fixed ratio. It doesn't change. We use the same ratio every time I'm talking about water. When I talk about salt, we always say NaCl. That's 1 sodium and 1 chlorine. It's a fixed ratio. It doesn't change whether I'm talking about salt or somebody else is talking about salt. We use chemical formulas to represent what a compound should appear like. So you will see a chemical formula that shows you exactly how many atoms you have. There's little numbers on the bottom. Those are called subscripts. And there's big numbers in the front. Those are called coefficients. The little numbers tell you how many atoms you have. The big number in the front tells you how many of the entire molecule H2O you have. So a 4 in front here indicates I have 4 water molecules. The 2 tells me on the bottom, the subscript, that I have 2 hydrogen atoms and 1 oxygen atom. So for example, let's look at another one. We have NABR. There's no numbers here. Not that that means that there's none, but that means that there's 1. So I have 1 Na, 1 Br. Fe2O3 would mean I have 2 Fe atoms and 3 oxygen atoms. Mg3PO42 means I have 3 Mg this parentheses I have to distribute the number in. So I have 2 P's and we multiply here 8 O's. The last one, I have 1 K atom, 1 Mn atom, and 4 oxygen atoms. Can compounds be broken down? Absolutely. So they can be broken down into the simpler form, the elements that make them up, by decomposition. So water is made up of hydrogen and oxygen. I can decompose water and form hydrogen and oxygen, so it can be broken down. A chemical change is also called a chemical reaction. So if I want to split water into hydrogen and oxygen, that would be a chemical reaction to change it into a new substance. During a chemical reaction, the composition changes, since it's a chemical change. Here's an example of a chemical reaction. You've probably seen these before. 7th grade, you might remember where you have different reactants are on the left, what you're starting with, and on the right are what you're forming, the products. So left are the reactants, what you're starting with. You're reacting them together. What you're forming or making are the products. The arrow we typically read as yield. So the reactants yield these products. The arrow is what separates the reactants from the products. The left are reactants, right side are products. So in summary, today we talked about elements and compounds. Elements are made up of atoms. Different elements can combine chemically to form a compound. When they combine, they form a definite ratio. Elements, when they form a compound, do not keep their original properties. So when they have a chemical reaction, their properties change. And compounds can be broken down chemically. So looking back at our matter chart, today we discussed the left-hand side, the substances. Substances are things that have a definite composition. There's 2 types of substances, elements and compounds. Compounds can be broken down into elements. They're broken down chemically if they are going to be separated. So a chemical reaction would need to happen to break a compound down into its elements. Once that happens, the properties of the compound will be different than those properties of the elements.